So what you all know about even and odd function? When do we say that a function is even? That you know. How we are going to use it for finding Fourier series expansion? Do you remember?
Yes, ma'am.
When do we check it for Fourier series expansion?
If f
First
of
of
minus
all,
x is equals to f of x, then even no.
correct. If f of minus x is equal to f of x, then the function is even. But when check whether the function is even or odd, ये कब check करना है? If your midpoint is 0, if the interval which is given to you, the interval f of x which is given to you, if that interval, let me just, yeah, f of x is the function which is given to you in the interval minus l to n, in the interval minus l to n, then only you are going to find whether the function is even or not. Is that okay? Not always. Because for even or odd, f of minus x is equal to f of x means what? You're trying to identify what happens for positive x and negative x. If it is same, then it is said to be even. If it is opposite, then it is said to be odd. Isn't it? Yes, students?
Yes, ma'am.
What is
Yes,
the meaning
ma'am.
of f of minus x? Yeah. f of minus x is equal to f of x का meaning क्या है? F of minus x is equal to minus f of x means what? The value of the function at minus x. If it is becoming negative of the function, then it is said to be odd. If it is becoming positive, then it is said to be even. Okay, so that means you are talking about the relation. X is positive here and x is negative, right? And you're saying that if the image is f of x, so this is f of x. If this is f of x and this is minus f of x. F of minus x. If it is same, then you say that f of x is same as f of minus x, then we say that the function is even, correct? Yes or no?
Yes, ma'am.
Yeah.
Yes, ma'am.
So that is what is happening. Suppose your curve is like this. Suppose this is coming like this. This is f of 0, f of 0. Then maybe some your x by 2, f of x by 2. If same images are coming this side, then we say that the function is even. Correct? F of x by 2, f of minus x by. F of say x by first x by 4, then x by 2, x by 3 like that. If the images are same, then your curve will be like this. So you can see what I'm trying to draw. Everyone? Yes or no?
No, ma'am, not got.
Okay, let me just see. This is say this is x. This is x. This is x by 2. This is minus x by 2. So if f of this is x, then what's the image of it? F of x is the image. Then f of x by 2 is the image. On the same line, if this is f of minus x, this is f of minus x by 2. So image is becoming on the y-axis. Yeah? So they are coming up to the same. So how to draw the curve with joint these images? Isn't it?
Yes, ma'am.
So what is happening? Whatever the curve is behaving here, same way the curve is behaving here, and the area which is covered by the two curves is getting covered. So even function geometrically, what it represents that if your curve is like this, then this function which is defined between 0 to say L, how do we get it even? If between 0 to minus n also it is behaving like this and the area is getting covered. यहाँ पे f of x है तो यहाँ पे f of minus x है. Same image आ रही है. Y coordinate same है. Y coordinate same है. So this function is said to be even function. Geometrically. Arithmetically. अभी समझ में आया कि मैं क्या ड्रॉ करने की कोशिश कर रही हूँ. ये f of x है और ये f of minus x है. दोनों की इमेज जो है सेम है. x अलग अलग है लेकिन इमेज आर सेम. y सेम है. Yes or no? Are you getting it or no? अभी भी नहीं समझ में आ रहा है.
Yes, yes, yes.
Are you understanding? F of x. If it is same as f of minus x, then I say that the function is even. Yes or no?
Yes, ma'am.
Yes, ma'am.
But what is the
Yes,
meaning of
ma'am.
f of x? उसकी y की इमेज ना, ये कौन सा x है, तो उसकी y की इमेज मतलब क्या रहती है? दिस इज f of x, तो y की इमेज ये रहती है, ठीक है? So this is your x, this is your x, then f of x. उसी तरह से ये जो है minus x है, y की इमेज वो भी सेम आ रही है. So then when you draw the curve, what is happening exactly? यहाँ पे जैसे curve 0 तो L में जैसे curve ये बना था, वही यहाँ पे होगा. So your area is getting converted and the function is becoming even. Is this okay now?
Yes.
वही अगर आपका function hot है, so suppose this was the function, okay? Then if this is say x, any x, and this is your f of x. When it is minus x, what will be f of minus x? कहाँ होगा वो यहाँ पे? So what will be your curve? Are you getting it? F of minus x. It is becoming minus of x. समझ में आ रहा है क्या? Are you getting it? हाँ. So f of minus x is nothing but minus of f of x. ये जो वैल्यू थी f of x की, ये वैल्यू वही माइनस क्या है? माइनस f of x. Is this okay? So what is happening? Here the area is opposite to each other, a and minus a. So they are cancelling it out each other. तो odd function के लिए कर्व ऐसे बिहेव करेगा, even function के लिए कर्व ऐसे बिहेव करेगा. आ रहा है? ज्योमेट्री के लिए समझ में आ रहा है क्या?
Yes, ma'am.
But where what are doing? You are thinking totally about origin क्या होता है? This is your origin ना. तो origin के left hand side में क्या होता है? Left hand side में क्या होता है? That you are checking. So Fourier series का expansion अगर आपको even odd के लिए देखना है, तो your function f of x is there. It may be x, x, or whatever it is. It should be defined in the interval minus x and then on x. जब फंक्शन इस रेंज में डिफाइन होगा, that time only you are going to try to find out whether the function is even or not. अगर वो 0 से try करते 0 से 2 पा रहे हैं, so then the symmetry is not origin. It may be something, it may be something like this curve, like this curve. Are you getting it? This curve, you are not going to check whether it is even or odd because we are not talking about the f of minus x and f of x. यहाँ पे सभी x positive ही है. So we are not going to think about whether f of plus x, what is becoming, what's the relation between f of minus x and f of x. So Fourier series expansion, अगर आपको even odd का formula use करना है, then what's the first thing that you have to cross check? You have to cross check whether the range which is given is minus n to n. Is this okay? Is this clear?
Yes, ma'am.
Okay, fine. So I'll give you. We'll try to solve the examples on this, then you'll understand more clearly. But ये मुझे क्यों आपको बताना था? क्योंकि ये extension हम लोग half range cosine series, half range sine series में करने वाले हैं. कि what is the meaning of extend the given function as even? अगर even करके मुझे extend करना है तो कैसे extend करेंगे? और करके अगर extend करना है तो कैसे करेंगे? That we are going to see in half range. But for that, first of all, you should know what the meaning of symmetry. Symmetry कहाँ होगी? Origin क्या है? लेफ्ट हैंड साइड में f of x है, राइट हैंड साइड में f of x है, तो लेफ्ट हैंड साइड में f of minus x है. तो वो what's the relation between that we have to check. So that we are going to see ahead. But right now, first of all, when we want to write down the Fourier series for even function or odd function, first thing that you have to cross check is cross check whether your range is minus l to a. Minus l to a. Okay. So take down the question. First question you take down. Obtain the Fourier series expansion. Obtain the Fourier series expansion. Obtain the Fourier series expansion of f of x. Obtain the Fourier series expansion of f of x is equal to x. F of x is equal to x in the range. F of x is equal to x. In the range minus pi less than equal to x less than equal to pi. Find the Fourier series expansion in the range f of x is equal to x in the range minus pi less than equal to x less than equal to pi. So what is the range given to you? What's the midpoint of the range?
0.
0. And that's why first thing that you have to check is You have to check whether the function is even or odd. What type of function is this now?
Odd.
Odd है. So
Odd.
odd के yes, very good. So if the function is odd, then what's your Fourier series expansion form? Once the coefficient 0 हो जाते हैं. We have seen this in the previous lectures that
A naught.
and
An.
becomes 0. Yes, sir.
Yes, ma'am.
So
Yes, ma'am.
only what remains is Bn. Okay. So if Bn is there, then you have to find out Fourier series expansion. So first of all, what we'll say? This you write later. Okay. First you write f of minus x is equal to minus x, which is minus of x. F of minus x is equal to minus of x, which is minus of f of x. Therefore, f is odd. Therefore, f is odd. Okay. Once f is odd, what we know? We know that a naught is equal to an is equal to 0. Bn is equal to 2 pi n integration 0 to n f of x into sine of n pi x by n. Is this okay? This is the Fourier series expansion. Is this clear? A naught is 0, an is 0, only what remains is bn. And what's the formula for bn? Do you remember this formula, or should I write the standard formula and then we'll see how do we get this 2 by n integration 0 to n? Everybody knows this?
Yes,
Or-
ma'am.
Yes, ma'am.
Okay,
Yes,
fine. So bn is this formula, and therefore what we will get now after this, if your function f of x is this, find the value of bn. Bn will become this. What is the period of the function? That we find with the help of this integral. Upper limit minus lower limit. Upper limit minus lower limit. So what is that? Pi minus pi 2 pi. Correct, na? 2x is equal to 2 pi. So n is equal to pi. And therefore, bn becomes 1 by pi into 2 by pi. We have written the formula. 2 by pi integration 0 to pi. What is f of x? X into sine of n pi x by n. So what's your bn? Your bn formula is 2 by pi integration 0 to pi x into sine of n x. Is this clear, everyone?
Yes, ma'am.
Okay, fine. So now what we have to use? We have to use Bernoulli's formula to find the product rule, integration of u into b. Do you remember what is the Bernoulli's formula? Right now. Bernoulli's formula for integration of u dx. What it is, I'll revise it. It is nothing but u into integration of b minus u dash into second integration of b plus u double dash into third integration of b and so on. Do you remember this formula?
Yes. Yes, ma'am. Yes, ma'am.
Yes. Hello.
Yes, ma'am.
Bernoulli's formula for product rule u into v. This is the generalization of your Weippert's rule. What we do over here is we keep u first as it is, first integration of t minus first derivative of u, second integration of u plus u double dash of second derivative of u and third integration of u and so on unless and until one of them becomes 0. This is the formula for Weippert's in generalized form. It is called as Bernoulli's formula of product rule. Is this okay?
Yes, ma'am.
Yes, ma'am.
Yeah. So what is u? U is your function. Use ideas. Inverse, logarithmic, algebraic, trigonometric, and exponential. So which is the function? X is algebraic, which comes first. So x will be u, x will be. I'll repeat the selection. The function which appears first in this bracket, indices, logarithmic, algebraic, trigonometric, and exponential. So algebraic means polynomial function or x function. So x is u, and which is a trigonometric function sin x, that will be v. So how will I write it here now? Just see. U is equal to x. So u dash. First derivative of u dash will be 1. Derivative of u will be 1. The derivative of x is 1. What's the second derivative?
0.
All the derivatives
Zero.
ahead will be 0.
Yes, ma'am.
Okay. So
Yes,
now
ma'am.
what is b? B is sin x. So what will be b1? First integration. Now u dash is derivative and suffix means
मैम वो
integration.
रूल लाइट रहता है ना
हाँ बोलो.
मैम वो रूल लाइट रहता है ना LIETE
Eyelid or line, both of them, this of both indices and logarithm have same convergence rate. So either you write li or in, each one is the same thing. The
Okay, ma'am.
process, yeah, the process is written because of the convergence rate. Logarithmic and indices, they give same convergence rate. That's why either you write eyelid or liate, it's one and the same thing. LIETE or LATE. Okay, no problem with that. Clear? Dr.
Yes, ma'am.
Yeah. So let's go to now first integration of v. Sin x का पहला integration क्या होगा?
Minus cosine x.
Correct. Minus cos nx upon n. Don't forget that n. Derivative of nx is n. Now that you write in the denominator.
Yes, ma'am.
Okay. One
Yes.
more. Yeah. You double x is 0 and integration of v is one more integration of this. That is minus 1 is constant. Cos nx integration of sin nx upon n. Is this okay?
Yes. Yes.
Okay. Yeah, fine. So now you substitute and you get the answer. So Pn becomes kind of what is this? Even or?
Yes.
So should I work this part?
Yes, ma'am.
Okay. So Bn becomes, therefore the value of Bn becomes Bn is equal to 2 by pi. The integration is u. I'm using this Verma's formula. U as it is. So x into first integration, that is minus cos nx by n. From where to where? 0 to pi. There, minus u dash. First derivative of x is 1 and second integration is minus sin nx upon n square. Next term onwards, there is no need to write because first derivative of 1 is 0. You substitute now the value and you get the answer. Just see now. When I put x is equal to pi, it is minus pi cos of n pi by n. Minus pi cos of n pi by n. When I put the lower limit, it is 0. Na? 0 into anything is 0. So 0. What about this term? Upper limit will become sin n pi, and lower limit will become sin 0. So what is sin 0? Sin of n pi, sin of 0 is 0. So this entire term becomes 0. Clear?
Yes, ma'am. Yes, ma'am.
And therefore your value of Pn becomes pi and pi gets cancelled minus 2 by n. What's the value of cos n? Who will tell me? Cos n pi.
-1.
Is it? Okay, good attempt. Cos n pi. Just see. When I put n is equal to 1, cos pi is minus 2. N is equal to 1. When n is equal to 2, it is cos 2 pi. So it is plus 1. Correct?
Yes, ma'am.
No, ma'am. Can you repeat again?
Yes. When I put n is equal to 1, it becomes cos pi. So cos pi is minus 1. When I put n is equal to 2, it is cos 2 pi. What is the value of cos 2 pi? Plus 1. Then when I put n is equal to 3, it is cos 3 pi. 3 pi is again minus 1.
Minus
So alternately, it is becoming plus 1, minus 1.
Yes. Yes, ma'am. Yes, ma'am.
Yes. And therefore, what's the value of
Yes, ma'am.
cos n pi in general? It is minus 1 raised to n. A number which is alternately becoming plus minus is written as minus 1 raised to n. Because put n is equal to 1 and check now what happens. You get minus 1. When you put n is equal to 2, it is plus 1. When you put n is equal to 3, it is -1. So alternately, it is becoming +1, -1. Okay?
Okay, ma'am.
Yes.
Yeah. So that's why your Bn value will become -2 upon n minus 1 is to n. Can you combine them together and get one fixed answer? I'm writing it down now. So what it will be totally Bn? How many minus ones are there? How many -1 signs are there?
2,
2.
1.
These are n. These are n and this is one more, na? So total n plus 1, isn't it?
Yes, ma'am.
Yes, ma'am.
So this is Bn is 2 upon n into -1 is to n plus 1. And that's why your Fourier series will now be f of x is equal to summation n from 1 to infinity 2 upon n minus 1 is to n plus 1 sine of n by x1 n is by pi minus x. So that's your answer. Is this okay? Everyone?
Yes, ma'am.
Okay. Please write it down quickly so that
Yes,
I will solve one more example on even on or two more examples on even and odd. Okay. So once you complete it, please tell me, then we go ahead. Okay. Which is that? ये वाली? This one. Okay. See here. Cos n pi value is -1 is to n. So this is -1 is to n and one more negative sign is there. So total how many negative signs? N plus 1. Na? So I wrote 2 by n minus 1 is to n plus 1. Is that clear? Now one? Okay. And that's why your final expansion is this. Okay, fine. So now let us go to one more example and you try to solve it. Okay, and wherever you get stuck up, please ask me. I'll help you out. Take down the question. Obtain the Fourier series expansion for obtain the Fourier series expansion for f of x is equal to pi square minus x square. F of x is equal to pi square minus x square in the interval minus pi less than equal to x less than equal to pi. Pi square minus x square in minus pi less than equal to x less than equal to pi. F of x is equal to pi square minus x square in the interval minus pi less equal x less equal pi. Okay, again midpoint is 0, so you identify first whether it is even or odd function. Okay, and then once it is even, you will have a not a n existing, bn is 0, and once it is odd, you have bn to be 0. A not an to be 0. So find out whether it is even or odd.
Even. Even.
Everyone is understanding that it is even.
Yes, ma'am.
Yes. Yes. So write down that step first, whether how it is even. So you identify whether it is even or odd function first, and then go for finding the values of a and okay. So f of x is this. So f of minus x. How do we find whether it is even or not? You have to find whether what is the value of f of minus x. So put in place of x minus x the whole square. So that will become again x square. So this is f of x. And therefore f is even function, f is even function which is symmetric about origin, and therefore Bn will be 0. Hence, Fourier series for f of x will be a naught by 2 plus summation n from 1 to infinity an cos of n by x by n. This is your Fourier series. So first, what you first next now you have to find the value of n. What's the period of the function? What's the period of the function?
Pi.
2 pi.
2 pi.
Period is upper limit minus lower limit. So pi minus of minus pi, that is 2 pi. And therefore n is pi. That's it. N is pi. So when you substitute n is equal to pi, your Fourier series becomes, what is the value of the Fourier series? F of x is equal to a naught plus summation n from 1 to infinity an as it is cos of nx. Is this okay? Cos of nx.
Yes, ma'am. Yes, ma'am.
N is equal to pi. So pi and pi will get cancelled and you get cos nx. A naught plus summation n from 1 to infinity an cos nx. Clear na?
Yes, ma'am.
So now go ahead and find what's the value of a naught and an. Find the value of a naught and an. Quickly, please. What is a naught? What's the value of a
A
naught?
naught is 4 pi
4
square
pi
by
square
3.
by 3.
Very good. That's nice. A naught is equal to, the formula is 2 pi 0 to L f of x dx. That's the formula for a naught. And what is that equal to? This is equal
4 pi
to
square.
2 by pi. Yes, 2 by pi 0 to pi square minus x square dx. And that will give you a naught is equal to 2 by pi. Pi square integration is pi square x minus x cubed by 3 from 0 to pi. So substitute and check. This is 2 by pi as it is. When you put the lower limit, it is going to be 0. So only upper limit will give the answer. So it is pi cube minus pi cube by 3. So 3 pi cube minus pi cube is 2 pi cube. 2 into 2, 4 pi cube by 3, that is 4 pi cube. 5 into 3, that becomes 4 pi square by 3. That's the value of a. Is this clear? Everyone?
Yes.
Yes, ma'am.
Okay.
Yes.
Now the same let's clarify what is an will become 2 by pi integration 0 to pi. Okay, f of x, that is pi square minus x square. Pi square minus x square into cos of nx. The importance of writing this Fourier series is whatever is a written with. A is the coefficient of cos nx that will appear in the integration. Pi square minus x square into cos nx. So your an value becomes 2 by pi integration 0 to pi pi square minus x square into cos of nx. Again, what are you going to use? Which method you are going to, which formula you are going to use here? Bernoulli's formula only?
Yes.
Yeah.
Yes, ma'am.
So for Bernoulli's formula, u into v, what I want to do that, who is u and who is v? Yes, the student who asked me, I did and v it. Tell me which is who is u and who is v? Algebraic will come first, that will be u, and trigonometric will come later, that is v. So who is u and who is v?
X square is u and pi cube is v. Pi square is
This is entire one function, na? Pi square minus x square.
it will
Pi
be
square minus x square is u and cos nx is v.
Very correct. Pi square minus x square will be u and cos nx will be v, because cos nx is trigonometric function. So that will be V and pi square minus x square will be U. So do this Bernoulli's formula and take the answer. To complete this, by then I will then solve that test. Then there will be less space. If you want, I will write down the U is pi square minus x square. U dash means minus 2x. U double dash means minus 2. And triple dash onwards it is 0. Then V is cos nx. So V integration 1 will be sin nx upon nx. V2 will be minus cos nx upon n square. And V3 will be minus sin nx upon n. I hope everybody knows the integration formulas. First integration of cos is sin nx by n. Second integration will be minus cos nx by n square because that 1 by n is already present. And then V3 will be minus sin nx. Integration of cos is plus sin n, but that minus sign will carry forward and it is minus sin x upon n cube. 1 over n will be multiplied in the denominator. Is this okay to everyone? I'm going very
Yes.
slow so that you can understand it very nicely. So V is cos nx, V1 is sin nx by n, V2 is minus cos nx by n square, V3 is minus sin nx by n cube. All this we have to substitute in the Bernoulli's formula and we will get the value of Vn. So what is that value of Vn? Let us check.
Ma'am, an is equal to minus 4 into minus 1 raised to n upon n square.
Okay, let us cross check. Okay, I think so. That's right. Right. So that's why An will now become equal to U into the Bernoulli's formula. Do you want me to write Bernoulli's formula once again, or should I directly substitute and write down the answer?
Directly.
Okay, okay, fine, good. So it is U. U is pi square minus x square into V1. V1 is sin nx upon n minus first integration of this V1, U dash, that is minus 2x into one more integration of this, that is minus cos nx upon n square. And then plus minus one more derivative of minus 2x, that is minus 2, and one more integration of minus sin x, that is we have written on this two sides on the right hand side. That's why I'm writing it again and directly put the limits. So 0 to 5. 2 by 5, we will write it outside. Don't forget to write out. An is equal to 2 by 5. This 2 by 5, we should not skip. Okay, now just see generally, many students they put the values and they cross check it. Always keep it in mind that what is when you put x is equal to pi, sin n pi will be 0 as well as sin 0 is 0. Is this clear to everyone? When I put the upper limit,
Yes, ma'am.
sin pi, that is 0, and the lower limit sin 0 is 0. So no need to check for anything. Directly this term will become 0. Same thing with this also. Sin pi and sin 0. So this term will become 0. Only you have to think about the middle term, which is in terms of cos. So an, which is 2 by 5, how many minus signs? 1, 2, 3. So it will be minus 2x into cos of nx upon n square from 0 to 5. Lower limit, when you put x is equal to 0, it will be 0. Only upper limit will reduce. So this will become minus 4 pi. X is equal to pi divided by pi into n square cos of n. So pi and pi gets cancelled. Therefore, an becomes 4 upon n square. We wrote cos n pi value in the previous example. It is minus 1 raised to n. And this one more minus sign. So minus 1. Is this clear to everyone? Have we got the value of an?
Yes, ma'am.
Yeah. So now you substitute this in the Fourier series expansion here, and that's your answer. So Fourier series expansion will be nothing but f of x is equal to a naught by 2. What we had got a naught? I think so it was 4 pi square by 3, na?
Yes.
A naught was, yeah. So 4 pi square by 3 divided by 2, because it is a naught by 2, plus summation n from 1 to infinity. An is 4 upon n square minus 4 to n plus 1 into cos of x. That's your concept. So simplify and write 2 pi square by 3 plus 4 summation n from 1 to infinity minus 1 raised to n plus 1 upon n square cos of nx. This is the Fourier series expansion of pi square minus x square in the interval minus 1 to 1. Okay?
Ma'am, cos n pi is 1 minus 1, na?
Cos n pi is minus 1 raised to n. Cos of n pi is minus 1 raised to n. Why? Because it is already plus minus sign. Na? So,
मॅम देन सेकंड लास्ट स्टेप मध्ये आपल्याला -4 पाय मिळालं होतं, मग ते मायनसची
how it
साइन
came minus n plus 1? How it came n plus 1 you are asking, na?
नो मॅम, इन सेकंड लास्ट स्टेप ए एन फाइंड करतोय ना आपण, तिथं सेकंड लास्ट स्टेप मध्ये आपल्याला -4.
This was minus 4. Cos n pi was minus 1 raised to n. So one more negative sign we got. Na? So I got n plus 1. Here n and this plus 1. So n plus 1. Is this okay now, Sanjana?
Yes ma'am, thank you.
Okay. Yeah. If still anybody has any doubt, please ask. Okay?
Okay, ma'am.
Yes. Let's do one more question on this. You try to. It will be a bit lengthy, but you try to do it. Okay?
Okay.
Should I give you?
Yes,
Should
ma'am.
I give the question? Yes. Please take down. Obtain the Fourier series expansion for f of x is equal to x minus x square. Obtain the Fourier series expansion for f of x is equal to x minus x square in the intervals minus 1 less than x less than 1. Minus 1 less than x less than 1. Yes. Who will tell me how to go about this? See now. Again, the interval is having midpoint as 0.
Yes.
Yes or no? Yeah. So you will be thinking about whether it is even or odd. What type of function it is? When I take it entirely the function, minus x will become f of minus x will become that x will become minus and x square will remain as it is. Okay. So rather than going for combined function, you do this way. Then it will be more easy. This is f1 of x minus f2 of x in the same interval. Can you see that?
Okay.
Now f1 you can clearly see that it is odd
Yes. Yes.
and f2 is clearly even.
Yes.
Yes ma'am.
So individually you write down the Fourier series expansion for f1, Fourier series expansion for f2, subtraction of the two will be of x. Is it okay? Yes. So please half or you all try for x, roll number maybe 1 to 35, try for x, f1x and 36 to 70, f2x. And then we'll write down the answer combined. Come on. You tried. And it's not x we have already done. Only what is the difference now? There the interval was minus pi to pi. Now the interval is minus 1 to 1. Okay?
Yes.
So try that way and see. I'll rub this version. Which one you think is difficult that I will try? I will do. X वाला आप लोग की सभी x square वाला मैं करूँ?
Yes ma'am.
Okay.
Ma'am, we are having the expansion of f of x is equals to x.
For what purpose and for the when period has to be पाई 2l इज इक्वल टू 2 पाई सो l इज इक्वल टू पाई अभी यहाँ पे फंक्शन क्या था इंटरवल कौन सा था -1 से 1 ना दैट्स व्हाई वी हैव टू पुट दैट l इज इक्वल टू 1 सो योर f of x is nothing but f1 of x minus f2 of x f1 of x is x in the interval -1 less than x less than 1 इसके लिए आप ट्राई करते हो and I will do f2 of x which is x square in the interval -1 less than x less than 1 f2 of minus x is minus x the whole square which is x square and that is f2 of x therefore f2 in even function f2 is even function hence what bn is 0 hence bn is 0 for even function bn is 0 okay now we have to find a naught and an so 2n is equal to upper limit that is 1 minus or minus 1 that is 2 so 2n is 2 that means n is equal to 1 formula for a naught is 2 by integration 0 to n of x dx. Therefore, we will get a naught to be equal to 2 by 1 integration 0 to 1 f of x मतलब f of यहाँ में क्या है f2 of x. So what is f2 of x? X cubed by 3 from 0 to 1. So a naught turns out to be 2 by 3. A will become 2 by 1 integration x square into cos of n by x by 1 because n is 1. So this n by x. So a is 2 0 to 1 x square cos of n by x. Okay. So you are going to arrange this Bernoulli's formula. X square is u, cos n by x is b, and we will get a and therefore is equal to 2 times what it will become? X square element is cos of n by x का integration sin of n by x upon n by minus x square का derivative 2x cos of n by x upon n square by square. Then I'm writing plus 0 because it will have sin of n by x will say lekin sin of n by x will have to put from 0 to 1. You can write same way in your exams also. The next term will be 0 because one more integration will be sin. In sin the integration when I put x is equal to 1 sin n by is 0 sin 0 is 6. Similarly this one is also 0. So only the middle term remains and therefore an becomes minus 4 upon x square by square into bracket x cos of n by x from 0 to 5. So when I put x is equal to 1, it will remain x is equal to 0 into vanish. So it is nothing but 4 upon n square by square into minus 1 is to cos n by. 1 put करोगे तो cos n by आएगा. Cos n by is minus 1 this square. That is one more negative sign. So minus 1 this square. Is it okay? And therefore,
Yes, ma'am.
and therefore, your Fourier expansion for f2 of x will be nothing but a naught by 2. What we have got? A naught
2 by 3.
Yes. So it is 2 by 3 upon 2 plus summation n from 1 to infinity 4 upon x square minus 1 is n plus 1 cos of n by x. This is f2 of x. This is f2 of x. Okay. Have you all got f1 of x?
मैम हमने an के लिए और एक टर्म क्यों नहीं लिया?
क्या? Please ask there.
मैम वो
Aaron?
मैम x स्क्वायर के बाद 2x और उसके बाद 2 भी एक रह जाएगा डेरिवेटिव.
X square का डेरिवेटिव 2x Very good. Then the next term is derivative of 2x is 2. And one more integration of course will be sin. Na? So sin of जब मैं x is equal to 1 put करूँगी तो sin n pi भी 0 हो जाएगा, sin 0 भी 0 हो जाएगा. इससे 0.
Yes,
And
ma'am.
this
Yes,
term
ma'am.
also becomes 0. But if I have written here only 0, you would have not got this term. That's why I didn't make the first one directly.
Yes, ma'am.
In exam also you can directly write down the third term 0 because you mentioned the reason. Sin n pi means n 0 are 0. That's why this term is. Okay. Yes. How many of did you get the expansion for f1 of x? f1 of x का expansion आया. f1 of x क्या था? x. उसमें it's odd function. So only bn will remain. A not a will be 0. So what the value of bn? I के bn की value.
Ma'am, is it 2 in bracket minus 1 raised to n plus 1?
Let me just. I think so. That's right.
Yes, ma'am.
2 into minus 1 raised to n plus 1 upon
Upon
n
n
pi.
pi.
Very good, very good. Maximum of you all have got this answer. This is absolutely right. Huh? 2 into
Yes, ma'am.
minus 1 raised to n plus 1 upon n pi. Have you all got that? All students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Shreya, Urmi,
Yes, ma'am.
Shraddha,
Yes, ma'am.
Siddharth,
Yes, ma'am.
others?
Yes, ma'am.
Yeah, maximum students got it, na? Okay. So f1 of x turns out to be summation n from 1 to infinity 2 upon n pi minus 1 raised to n plus 1 sine of n by x. And therefore, what will be the Fourier series for f of x? It will be the Fourier series of f1 of x minus the Fourier series of f2 of x. So first is this 2 by 3 upon 2 we got. That's 4 by 3. Correct? Almost. 2 and 2 we cancel, na? 1 by 3. Yes or no?
Yes, ma'am.
So 1 by 3 will come later because that is f2 of x. First we have to write f1 of x. f1 of x is summation n from 1 to infinity 2 into minus 1 raised to n plus 1 upon n pi sine of n pi x minus 1 by 3 minus summation n from 1 to infinity 4 upon n square pi square minus 1 raised to n plus 1 cos of n by x. That's your Fourier series expansion for the function x minus x square. Is this clear to everyone? सभी को समझ में आया क्या?
Yes. Yes, ma'am.
Yes. So that's about even and odd function. When you're going to go for even and odd function identification, if your midpoint is 0, then only you'll go for even and odd function identification. Once you identify that it is even function, who will become 0? Bn will become 0. And your a naught an you have to find with the formula 2 by L integration 0 to L f of x or f of x into cos term. And if it is odd, then a naught an will be 0. You have to find bn formula and then write down the Fourier series expansion. Is that clear, everyone?
Yes, ma'am.
Yes, ma'am.
Okay. Fine. So that is about even and odd. In the next lecture, we are going to see half range Fourier series, cosine and sine. That we'll do tomorrow. And you take one more question for homework and try this at home. Okay. Should I give you the question?
Yes.
And
Yes.
this is a bit different question, but still you try to solve it. Don't go for even odd. Directly go for solving the Fourier series. Okay, take down the question. Find the Fourier series for f of x is equal to I'll write down. Should I write this? F of x is equal to 0 in minus n less than x less than 0 and 1 in 0 less than x less than n minus n less than x less than 0 and 1 for 0 less than x less than n. Here also the midpoint is 0. Here the midpoint is 0. But can you see that can you identify immediately that it is even or odd function? Is it easy to identify quickly that it is even or odd function?
No, ma'am.
No. So whenever this happens, now directly go for finding a not a and b n. Don't go for finding whether it is even or odd. Okay, directly go for finding a not a and b n, and then if it is odd, then a not a n both should become 0. If it is even, b n should become 0. Okay, so find the Fourier series expansion for this. Also, take down the ahead question. Also, find f of x. Find f of x at the point of discontinuity. At point of discontinuity. At the point of discontinuity. What is the discontinuity? At the point of discontinuity. Which point is this? At which point the function is discontinuous?
0.
Very good. Do you understand why it is discontinuous at 0? Because there is a break at 0. Yeah, it's not defined also, but left hand limit and right hand limit is defined. The point of discontinuity x is equal to 0. And generalize the definition. Generalize the definition of function at discontinuity. Generalize the definition of function at discontinuity. Everybody understood the question? Did everybody understand the question? You have to find the Fourier series expansion of given function which is distributed. Okay. So what you have to do next? You have to also find the value of the function at the point of discontinuity. So point of discontinuity is 0. Left hand limit of 0. What is the left hand limit of 0? How is f of x approaching from left hand side? At 0. It's given in the definition.
0.
Yes, Shailesh, what is the left hand limit? Can you tell me? Just see. Left hand limit is 0 for left hand side se negative number. What's the value of the function?
0.
Yes, say confidence clear or right. Left hand limit matlab 0 for negative side f of x is 0. Right hand side is 0 plus side. So what it is? 1. Okay, and the definition actually is average of the left hand limit and right hand limit. The point at discontinuity, what we have is value of the function is average of the left hand limit and right hand limit. So what is the average of left hand limit and right hand limit?
0.5.
Half, correct, absolutely right. So your answer will be half. But how are you going to get it? You are going to get it with the help of Fourier series expansion. So f of x will be half plus something. That means a naught will exist and a naught will be 1. So that a naught by 2 will become half. Because what's the constant part of a Fourier series? A naught by 2, na?
Yes.
Yeah. So that a naught by 2 will become half and remaining function will have x. But when x is 0, that will vanish. So if x is, when you put x is equal to 0, the remaining part is going, means is cos x term present in the expansion? I'm trying to get you the answer with the help of values that you know. F of x may a naught by 2 rahega because I want the value of f of 0. So constant part should be there. Okay. Now, when I put x is equal to 0, remaining part should go, vanish. So cos x का term रहेगा क्या? Cos x का term रहा तो x when I put 0, it will become cos 0 is 1, na?
Yes.
So if cos term is there, that means that part, that summation part will remain. So hence, in the Fourier series expansion, cos x term should not be there. Means a n coefficient should be 0. Are you getting it? A n 0, cos 0 नहीं कर सकते directly. But if a n is 0, cos n by x by n into 0 will be 0. So that term will go. So a n should be 0. And b n may exist. Because sin 0 is 0. So bn find करना पड़ेगा. A naught will be there. An will be 0. That's your answer. And f of 0 is half. Okay, so these things you try to prove. You try to see whether you can find it. Tomorrow we'll see in the class. Okay, ठीक है?
Okay.
Just a second. Let me take your attendance quickly.